In this video, we're going to look at when we use letters rather than numbers for uniform acceleration, and it's exercise 2E. So a train accelerates uniformly from rest to a speed of v. It continues at this speed for a period of time, so my constant, and then decelerates to rest. In travelling a total distance of d meters, the train accelerates through a distance of pd meters and decelerates through a distance of qd meters. P is less than 1 and q is less than 1. Draw a speed time graph for the motion of the train. Well, that will help us. And if the average speed for the journey is v over p plus q plus b, find the value of b. So let's have a look at our speed time graph first, and that should help us then. And we follow the same rules here as we have done in all of these questions. Just when there's letters instead of numbers, it's hard to see where it's going, and it does take a little bit longer to simplify. So here's my speed time graph. Accelerates to a speed of v. What other information have they given us here? Just the distances travelled. So time doesn't look like it's been given to us here. So we'll call these intervals time 1, time 2, and time 3. Total distance they've given us. What's the total distance? Was d, wasn't it? D meters up here. Total distance is d. They've also given us the distances travelled. In the acceleration was pd and qd in the deceleration. So here we have pd and here we have qd. So that means that the total distance in here is going to be d minus the two of them. So we have 3 distances travelled. So we could get in terms of time these distances. So let's have a look at doing that.
What did you say?
So recording videos at home lead to interruptions. So apologies for those. So we have half T1 times V is equal to PD. So in this one we have half of T3 times V is equal to QD. And in the rectangle we have T2 times V is equal to D minus PD minus QD. So if we simplify these down into, I'll number them 1, 2, and 3. In terms of the total time taken, T1, number 1, T1 is equal to 2PD, you can see here, multiply across by 2, 2PD divided by V. And the second one, T2 is equal to, well, I can factor out the D here. I'm not sure if that'll help me, but let's factor out the D. It's going to be D times 1 minus P minus Q, and we'd have to divide by V. And in the third triangle, we have T3. Will have to be equal to 2QD, not D, Q first, 2QD divided by V. So where are we going with this? So they have given us also the average speed. So let's write this down and see does it help us. Average speed, come across here, average speed is equal to V over P plus Q plus B. V over P plus Q plus B. Now what is average speed? Average speed is the total distance over the time taken, or the total time. So we could write total distance over time. We have the time now, these 3 things added together. T1, T2 and T3 is the total time, so we're going to have to sub that in. And the total distance we were given is D up above here. So this guy will have to be equal to D over T1 plus T2 plus T3. And that's where B is going to come in here, P plus Q plus B. So now it's just about subbing in and simplifying down. So d, let's cross multiply first. D times p plus q plus b is equal to v times, and you can see here there's a v on the bottom of all these, so the v's will cancel here hopefully, 2pd over v plus d times 1 minus p minus q over v plus 2qd over v. So definitely the v will cancel for me. Anything else can cancel? They all have d, and then I can divide across by d as well. And now just let me write out what's left. P plus q plus b is equal to 2p plus 1 minus p minus q plus 2q. So I want b on its own, so let's do the p's cancel. I think they do here, do they? 2p minus p is p, so we're going to end up with p and p cancelling. 2q minus q is q, so they'll cancel, so we're just left here with b is equal to 1. So questions like this that look quite complicated, we're following the same maths as we have learned in all the previous sections. Take your time, don't panic, fill your variables in, see what you can cancel, particularly at stages like this. Dividing across by q or v or whatever letter will simplify it for you. So let's go on and do exercise 2e. Question 1. A car starting from rest. So if you want to put your information in as you go, u is equal to 0, accelerates uniformly and travels a distance of d. Okay, s is equal to d in the first n seconds, so we have t is equal to n, and a distance of k, so s is equal to not just k, remember we're going to add these two intervals together, so s is going to be d plus k for this second interval, and another n seconds, so time is going to be 2n, and we're asked to prove that k is equal to 3d. Okay, so let's have a look at this. First distance is going to be ut plus a half at squared. So once you can see we're dealing with distance here. So we're going to get the distance in the first n seconds of motion. My u is equal to 0. My s I can change to d because we want d in the answer here. My t is equal to n. So s is equal to ut, 0 times n plus a half a by t squared, which is n squared. So my first distance is equal to an squared over 2, and we can say that that's d. d is equal to an squared over 2. So the second part, s2 we'll call it, we have t is equal to 2n, s is equal to d plus k. We're including the first part so that we still have my initial velocity being 0 and the acceleration is uniform. So s is equal to ut, 0 by 2n, which you don't need, plus a half at squared, so a by t 2n to be squared. My s is equal to d plus k, so d plus k is equal to 4an squared over 2, so 2an squared. Just be careful with you make sure you multiply the 2 by the power. We want k and 3d in the answer, so we have, if I can get 2an squared into the first one, we can equate them. So if I multiply this by 4 will give me 2an squared, so 4d is equal to 4 by the right hand side, which is 2an squared. We can then say that 4d has to be equal to d plus k, so 3d has to be equal to k, and is that what they were looking for? 3d is equal to k. Question 2. A car can move with acceleration 3a and deceleration 5a. Find in terms of k the time taken to cover a distance of 90 ak squared from rest to rest. Subject to a speed limit, so we'll have two triangles and a rectangle in part 1, and no speed limit will just be those two triangles that we've seen before. So let's draw this. So my time, my speed or velocity, there's going to be a limit here of 15 ak for my speed, 15 ak. So I'm accelerating to 15 ak, I'm continuing, and then I'm decelerating to rest. So what's going on here? Let's have a look. A is equal to 3a, and deceleration, I'll call it d, is equal to 5a. So we have our times here. Let's have a look at those. So we can get them with our velocity is equal to v is equal to u plus at. So in section 1 here, we got velocity, well, we know it's 15 ak, is equal to u, which is starting from rest on 0, plus a times t, so plus 3a times t. So my time is going to be 15 ak divided by 3a, which is going to give me 5k. So that's my time down here. And similarly, you can see here the time for the last one will be 3k. Let's have a look at that. So my velocity, well, my final velocity is 0. My initial velocity is 15 ak. And it's going to be deceleration, so minus 5a times t. So t is equal to 15 ak divided by 5a, which, as we said, is going to be 3k. So what can we say here? We know this, the total distance covered is 90 ak squared. So let's look at the distance covered in here. Half 5k by 15 ak is the distance covered in there. So that's 75 ak squared divided by 2, 37.5 ak squared. And this one, half 3k, half the base by the height, 15 ak. So it's going to be half of 45 ak squared, which is 22.5 ak squared. So these two are going to give me a total of 40 and 20, 60 ak squared. So we're told that the distance is 90 ak squared. So 90, 30 ak squared left, you can just write, you don't have to do 90 minus 60. Therefore, we have t by 15 ak is equal to 30 ak squared, the distance left. So t is equal to, it's going to be 30 ak squared, and I'm sure you can all see this in one step now, divided by 15 ak. So in this case, t is going to be 2k. So my total, I think we're asked for time in terms of k. Find in terms of k the time taken to cover a distance. So the time taken, the total, is 5k plus 3k plus 2k, which is equal to 10k, and that would be in seconds. 10k seconds. Part 2. We're subject to no speed limit, still the same distance, so no speed limit. So when there's no speed limit, we can accelerate up and come straight back down. So if we label our triangles T1 and T2 and my total time of T, we're going to have A is equal to 5A, my deceleration is 3A. So you can see here that T1 is going to be 5/8 of the time and T2 is 3/8 of the time based on what we've done before. So it's because of the ratio T1 to T2 is equal to the ratio of deceleration to acceleration the other way around. So that would be 5A to 3A. Just notice I've written these the wrong way around, 3A to 5A. So it means that we're coming in quicker. So we're taking longer to accelerate. So that's why these reverse around. So this is going to be out of a total of 8. So 5/8 is the longer time for t1. So 5/8 of the total time is equal to t1, and 3/8 of the total time will be equal to t2. I should be able to get my velocity now in terms of t. V is equal to u plus at. My velocity is 0. My acceleration is 3a. And my total time for t1 in terms of t is 5/8 t. So that's going in here. 5/8 times t. So my velocity, it's not going to give me 3 5s, 15 at over 8. So now I can get my area. Of both shapes at the same time. So half the base by the perpendicular height, which is 15a, and that should be, I should leave it as a capital T here. That's going to be equal to 90 ak squared. So I'm going to get 7.5, 15 divided by 2, a t squared is equal to 90 ak squared. So I can cancel my a's, and I can be left with t squared here. T squared is going to be equal to 90 divided by 75, 180 divided by 15. And I've left out my 8 here. 15 at over 8. So I'll just take out that 7.5, so it's going to be 15 at squared on top. And we're going to have 16 by 90 on the right hand side. So t squared is equal to 90 by 16 divided by 15 k squared. Does this work out evenly? 90 divided by 15 is 6, so we're going to have t squared is equal to 6 16s 96 k squared. So I can get t is going to be the square root of 96 times k. So t becomes root 96 of root 16 by root 6. It's going to give me 4 root 6 times k, and I think that's t in its simplest terms here for question 2. Question 3, we're told a particle is projected vertically upwards with velocity u, and its height is h after t1 and t2 seconds. Prove that t1 times t2 is equal to 2h over g. Okay, well, we look at the displacement of this. We're going to get s is equal to ut plus a half at squared. So that's going to give me my g. So s is equal to ut minus g over 2 by t squared, and displacement is h, its height, so we could say that h is equal to ut minus gt squared over 2. So if I multiply by 2, I'll get this 2h in here. 2h is equal to 2ut, multiplying everything by 2, minus gt squared. Now this looks like a quadratic. The quadratic is gt squared minus 2ut plus 2h is equal to 0. Now in the normal questions we'd solve this and get 2 values for t. So we could solve this and get 2 values for t. We could do it another way as well, but let me solve it first and get 2 values for t. So we'd be better off looking at this in terms of, well, what are they asking us here? This is the product of the roots. So we have a bit of knowledge about the product of the roots. This question actually is really straightforward from here, but if you don't know this, it's impossible to see the answer. So let's take a couple of quadratics that are easy to factorize. X squared minus 10x plus 24 equals 0. Is x minus 6 by x minus 4. So my roots, my factors and my roots are x is equal to 6 or 4. Now we put 6 times 4 as the product of these roots is equal to 24. That's also equal to c over a. This 24 over this 1 here that we don't see. And if we try that for, say, 6x squared plus 20x plus 6 equals 0. And then I can divide this by 2 to get 3x squared plus 10x plus 3 equals naught. So we're going to have 3x times x. We're going to have 3 times 1, and they're both pluses. So my roots are minus 1 over 3. And if I multiply, I'm going to say the product of the roots here. Minus 1 over 3 by minus 3 is equal to minus 3 is equal to 3 over 3, which is equal to 1. And if we look here, 6 over 6 is equal to 1. And 3 over 3 is equal to 1. So product of the roots is equal to c over a always. And the roots here are my t2 values for t when this projectile is at the same height. So what have we got here? C over a is 2h over g, which is equal to c over a, which is equal to t1 times t2. This knowledge of quadratics. Question 4. A particle moving in a straight line with constant acceleration passes the 3 points, P, Q, and R. Q is the midpoint of PR, and the speeds of P and R are u and 7u. Find the speeds at Q in terms of u. And I'm reading what I've written, but it's speed at u. You can't have plural speeds. So let's do a little diagram. P, Q, R. We call the distances x, P, Q, and R. Okay, what information do we have? We have a u and we have a 7u. So that's the initial speed at P. U is equal to u. Velocity, we don't know. We're looking for the speed at Q, so we're looking for v here. In terms of u, A, we don't know in terms of anything at R, so this is P to Q, and because we have final velocity at, we have u and 7u, so we may go P to R first here, and we know the distance is x. But if we look from P to R, we have my initial velocity is u, my final velocity is 7u, so that will help me here. We have more variables. A is equal to a, and s in this case is 2x. So we fill that in. What do we got? V squared is equal to u squared plus 2as. So 7u to be squared. So we couldn't do this in the first one because we just had a v and a u. So let's have a look here. 7u squared is equal to u squared plus twice the acceleration by the distance, which is 2x. So 49u squared equals u squared plus 4ax. That should help here. 48u squared is equal to 4ax. 12u squared is equal to ax. So we can get acceleration in terms of u and x, and we have an x over here, so this could help. A is equal to 12u squared over x. So now I have this acceleration here in terms of u and x. So I have a u, a v, and then in terms of u and x, the other one. So if I do the same formula, v squared is equal to u squared plus 2as. I should be able to get what v squared is. So u squared is just u squared plus twice my acceleration of 12u squared over x by my distance, which is x. Okay, we can see what's happening now. We're just going to get v squared in terms of u. V squared is equal to 24 plus 1, 25u squared. So v is going to be equal to the square root of 25 by the square root of u. Okay, there's a part 2 here. Show that the time taken to go from P to Q, so we're looking at t here, is twice that from Q to R. So the times taken, P to Q and Q to R. Time P to Q and time Q to R. So we have V is equal to 5u. My initial velocity was equal to u. I can leave my acceleration as a, in this case the same acceleration, and then time is equal to, what we call this, t1 and t2. So v is equal to u plus at. 5u is equal to u plus AT1 4u is equal to, not AT squared, AT1. 4u is equal to AT1. So T1 is equal to 4u over A. We're asked to show that that's twice the time taken from Q to R, so we should get 2u over A. So at Q, my initial speed is the 5u, and my final speed is, just double check, it was 7u, wasn't it? Because we had 49u squared. 7u. And then we have A being A, T being T2. So V is equal to U plus AT. 7U is equal to 5U plus AT2. 2U is equal to AT2. And you can see that's what we said we were looking for, 2U over A. T2 is equal to 2U over A, which is equal to T1 over 2.